Hello everybody, and today we are going to do Unit 8, Day 2 notes. And we're going to start by just reviewing some of the stuff we went over last class. For example, vertex, axis of symmetry, domain, range, and all that stuff. So first thing we're going to do is look at example 1, and they actually give you the equation for example 1 right here. And this is something that you probably haven't seen before. I mean, you've seen it before, but you haven't seen it in this form as far as it's a little different from day 1. But we're not really worried about the equation right now. The only thing really kind of what I would have you notice is that there is a negative sign that is going to flip this parabola or U-shaped into an N. So let's just do all the stuff. First, I recommend just start by getting the vertex. Always just, once you find the vertex, everything else is a little bit easier. In this case, we know that the vertex is -1, 4. And again, that is the place that it changes direction. Also, the highest point or the lowest point. In this case, it is the highest point. So since the vertex is the highest point, meaning our maximum is defined, this is a maximum problem. Now, your axis of symmetry, again, is just your x value of your vertex. Okay, meaning if I draw the dotted line at this place right here, it would be symmetrical on both sides. Domain, again, is -infinity to infinity. Always, it's a list of x values or inputs that I could use. Range is the lowest value of y to the highest value of y. So my lowest value of y is down here, all the way at the -infinity location. My highest value of y is 4. My x-intercepts and my y-intercepts, and as x approaches positive infinity, remember, if the parabola is facing down, these are going to be -infinity. If it's facing up, it would be positive infinity. So that's what's happening to the y values. The x-intercepts are the place that it crosses the x-axis. Sorry, that's the y-axis. So it's the place that it crosses the x-axis. Looks like it has 2 x-intercepts. Right there, and it looks like they are going to be at 1, 0 and -3, 0. There you go. Remember, they are points. The y-intercept here, it looks like it also, well, just has 1. It's going to be that one right there, and that looks like it's at 0, 3. Increasing and decreasing intervals. So this is where the U is increasing. So scaling from left to right, it looks like it's increasing from -infinity to the x value of the vertex, which is -1. And then it's decreasing as I ride down this roller coaster from -1 to positive infinity. Okay, a vertex form, we talked a little bit last class what vertex form was, but here's just some notes for you there. Vertex form is going to look like this, and we're dealing with that today mostly. Remember that this right here inside the parentheses is the x movement or the shift from left to right, okay? And this is going to be movement up and down, or the y movement of the vertex, right? Okay. And we're not going to take time filling all that in, but I would just make note of that right there. Okay. So today, mainly what you're going to be doing is you're going to be creating a table or a list of inputs and outputs for these equations. You are also going to, fill in some information. So here's how you do it. First thing you need, these are in vertex form. Okay, all these will be in vertex form. And so what we need to do is start by identifying the vertex and put it in the middle of the table. Okay, and if you follow, my steps here, this will become, pretty straightforward. So vertex, I already just found out what that is. That is -4, -2. Okay, so I'm going to fill in these points later. I'm not going to do all the points right now. I'm just going to go piece by piece. The domain we can go ahead and do. It's a list of possible x values. Here it's just -infinity to infinity. Again, the axis of symmetry is just the x value of the vertex. Why don't we fill that in now? Now it comes to the table. This is something new. that we haven't really talked about. Okay, so when you're making a table of values here, what I recommend is putting your vertex in the middle. Okay, once you have that, what I do is I go up 1, up 2 on this side, and then I go, well, that's technically down. Down 1, down 2 on that side, and then I go up 1, up 2 on that side. And it doesn't necessarily matter which side you put the up and down on, but you need to be consistent. So if I put my ups on this side over here, then, make sure you put your ups on that side and, put your downs on that side. And then conversely, if you put your ups on this side, make sure you put your downs on that side. So just, stay consistent there. Then you need to find your output. So these are the inputs. Okay, that's what I'm going to input to the equation to shoot me an output. So I'm going to do one of these, actually write it out, and then I'm just going to kind of do calculator work from there. So my input, if I were to put the input into this equation right here, it's going to look like this below. So it's going to be my output equals my input, which is -5, let's just use that one, plus 4 squared minus 2. And remember, we do stuff inside the parentheses first. So that's going to be -1 squared minus 2. And then I'm just going to have equals y equals 1 minus 2, because -1 times -1 is +1. Y equals -1. There you go. Boom. Okay, and then next I'm going to do it for -6 as well. So I got y equals -6 plus 4 squared minus 2. So I'm going to get y equals -2 squared minus 2. Y equals 4 minus 2. Y equals 2. So that's going to be a 2 right there. And then if you go up 1 on one side, then if you go down by the same amount, these are automatically going to be the same numbers on the other side. So, make sure you go up by those amounts. Now it's time to graph. So I'm going to have -4, 1, 2, 3, 4, down 2, 1, 2. Great. And then I'm going to graph my -5, -1, which is right there. I'm also going to graph the other side, -3, -1. And then I'm going to have -6, okay? Well, let's just go to the other side. -2, and then +2 as my output. Okay, there you go. I'm going to have the other one that looks like this. Therefore, I have a parabola that looks something like that. And the reason why I did this before I did the range is because it makes it a lot easier for me to determine my range once I have a graph drawn. Remember, the range is the lowest value of y to your highest value of y, okay? In this case, it's not flipped, so -2 is my lowest. My highest value is it goes all the way up to infinity. Last is translations. We talked briefly about this last class. Translations is the way the vertex moves. Okay, so I'm just going to describe the vertex movement here. It looks like we went left 4 units, down 2, and boom. That's it. That's all we did on that one. Okay. All right. So we are going to go down to the next one, which is this 1/2 x squared minus 3. Okay. I did that because you got a fraction in there. Again, we have to find the vertex. But what you're going to notice about this is it looks a little different because it doesn't have that parentheses in the middle. So I'm going to actually rewrite this out so you can see what's happening here. Okay, if I were to just rewrite this out, this is what this would look like. They don't put the 0 in, so, you got that going for you. I already know my x value. It's going to be 0 for the vertex, and my y is going to be -3. Okay, so I can already fill in my vertex down here. Okay, the axis of symmetry, again, is just the x value of your vertex, so There you go. Domain, we can fill that in. Why not? Negative infinity, positive infinity. All list of values of x I can put in for. The range, we're going to wait. In the translation, we are going to wait as well. So, all right, here we go. And now we're just going to fill in our values. We're going to put 1 and 2 up here. We're going to put -1 and -2 right here. It doesn't really matter because they're going to be the same on both sides. And matter of fact, I actually want to change this. And the reason why I want to change it is because this 1/2, I kind of actually want to do even numbers. And I'll show you why here in a second, why I like even numbers for this one. All right, so we're just going to put our inputs in. I'm going to have y equals 1/2 parentheses 2 squared minus 3. And the reason why I did this is because when you get this, you're going to have 4 minus 3. Well, what's 1/2 times 4? Well, it is 2 minus 3. So y equals -1. There we go. Great. I have this both for me there. All right, now the 4, the 4 is you're gonna handle the same way. I'm gonna do it rather quickly to save a little time, but it's gonna be 1/2 times 4 squared minus 3. And it looks like our answer is 5 here. All right, so there you go. 16, 8 minus, 3, that's 5. So now we just got to graph it. So we're going to have 0, -3, which is 1, 2, 3 right here. And then we're going to have 2, -1, which is right here, and -2, 1 right there. And then 4 and 5. So we're going to go over 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. There you go. 1, 2, 3, 4, 5. Sorry, 4, and then up 1, 2, 3, 4, 5. There you go. So I have this U. And the thing I like about this U is, we'll talk about it in translations, it's a little longer U, or it's kind of stretched out a little bit, which will be important right here. This number right here identifies the stretch or the shrink, okay? So let's go into here real quick. So the range, now we can do the range. Lowest value of y to the highest value of y. So my lowest value of y is -3. My highest value of y is infinity. Now translation here, what we got is we went down 3, and it is a stretch. All right, it is a stretch, meaning that it stretched out to be longer, kind of more of a U-shaped. If, for example, this number right here, what you're going to notice is it's a 2, this is actually what we call a shrink, okay? Meaning the U is going to go up a lot faster, okay? That is a shrink. And if it's less than 1, okay, if the number outside, we call it A, if A is less than 1, it is a stretch. If it's greater than 1, if A is greater than 1, it is a shrink. So make sure you have that. It might come in handy later. All right, let's do the last one. We got a little bit of time. I'm going to breeze through it real quick. Remember, there's a negative out here. This means it's going to be a flip. So let's get right into that right now. So my vertex is -1, 5, because remember, it's opposite what you see in the middle. So here I'm going to have -1 and 5. Next, I'm going to go up 1 and down 1 on both sides. So let's just go up 1 on this side. Let's go down 1 on this side and fill in all of our stuff here. Okay, so now I'm just going to fill in my stuff here. I'm going to try to do this rather quickly. I'm just going to do my inputs. So I'm going to have negative parentheses 0 plus 1 close parentheses squared plus 5. And that is a 4. Okay. Oh, did I forget the negative? Nope, that's right. Okay, great. Next, I'm going to have this -2 here, so I'm going to have negative 2 plus 1, close parentheses, squared plus 5, and that is, again, 4. I know they're going to be the same. Now I'm going to have -1, okay, plus 1, which is 0, and then plus 5. So let's do that. 5, and that is 1. Okay. And then I'm going to know that is 1 as well. Now it's time for me to graph. So I have a graph here, and it starts at -1, comma, 5, 1, 2, 1, 2, 3, 4, 5. Boom, right there. Next I have 0, 4. So it's 0, 1, 2, 3, 4, right there, right there. Next I have 1, comma, 1, which is right there and right there. And let's kind of draw this graph out the best I can. So now the domain, again, is -infinity to infinity. The axis of symmetry is going to be x equals -1. Remember, it's the x value of vertex. The range changed a little bit because it's flipped. Lowest value is -1. The highest value of y is 5. Translations, it looks like I went left 1, up 5, flipped. Great. Okay, and that's it. That's all you got right there. Have a good day.